Mercury sits as the first planet from the Sun, enduring a terrifying reality where one single day lasts longer than 2 entire years. For decades, traditional astrophysics treated this small world as a barren moon, but advanced space exploration now reveals a highly dynamic, deformed wasteland. Official telemetry documents from NASA indicate that this planet is actively shrinking, buckling its own crust into towering cliffs 3 kilometers high, while blasting a massive sodium tail 2,500,000 kilometers into the vacuum. This scorched remnant of a murdered planet fundamentally challenges our established space theory, proving that the closest boundary of our solar system is actually an iron prison shifting under intense cosmic forces. What they saw next would change everything we thought we knew. To begin this deep exploration, we must evaluate the familiar visual exterior that masks the true nature of the planet nearest to our central star. When observing its physical facade, Mercury presents a striking deception, appearing nearly identical to the moon orbiting Earth. It looks like a barren, dark gray sphere heavily mottled with crater scars, ridges, and vast plains created by ancient cosmic bombardments. Yet, despite this simple lunar appearance, data from modern astronomy proves that this body holds a far more complex identity. It is officially classified as the smallest planet within our solar system, a tiny rocky sphere that is barely larger than our own moon. For generations, casual observers dismissed it as a dead object, a simple baked rock with no internal activity. However, specialized investigations in observational astrophysics have exposed a reality that shatters these old assumptions, revealing an environment defined by some of the most violent physical dualities ever recorded. To understand the harsh environment of this world, one must examine the critical concept of atmospheric mechanics. On Earth, our thick atmospheric blanket plays a vital role in sustaining life by trapping solar energy and distributing heat evenly around the globe. This blanket prevents extreme shifts, keeping our world stable and comfortable. Mercury, by contrast, possesses almost no atmosphere at all. Instead of a thick protective shield, it is surrounded only by an extremely thin, tenuous gas layer known as an exosphere. The molecules within this exosphere are gravitationally bound to the planet, but their density is so incredibly low that they practically never collide with one another. Consequently, this world lacks any structural insulation to store or manage the immense thermal energy flowing from the sun, leaving the bare ground completely vulnerable to the raw, unshielded forces of deep space. This complete absence of a thermal blanket leads directly to an extreme physical consequence, creating the largest temperature disparity found anywhere in our local planetary family. Without air to regulate incoming radiation, daytime on Mercury turns into a monstrous furnace. At local noon, the scorched surface is bombarded by solar rays that are 7 times brighter than those hitting Earth, driving ground temperatures up to an incredible 430 degrees Celsius. This intense heat is hot enough to melt solid lead into liquid puddles and turn ordinary spacesuits into ash within moments. Yet, the moment the slow rotation forces the ground into the dark side of the planet, the reality reverses completely. Because there is no atmosphere to trap the accumulated heat, all thermal energy escapes instantly back into the cold vacuum of space. Within a matter of hours, the temperature crashes down to a freezing -180 degrees Celsius, shifting the landscape from a blazing pizza oven to a frozen cryochamber. Amidst this terrifying cycle of fire and ice lies an extraordinary physical paradox that continues to captivate researchers producing any modern science documentary. At the northern and southern poles of the planet, there are deep impact craters containing unique geographic structures known as permanently shadowed regions. Because Mercury rotates on an axis that is almost perfectly straight, with a tilt of only 0.027 degrees, the sun always hangs low on the horizon at the poles. The steep, towering walls of these polar basins block out the sunlight entirely, creating pockets of eternal darkness that have never seen a single ray of light for billions of years. Within these cold sanctuaries, temperatures never rise above -93 degrees Celsius. As a result, Radar instruments operating from Earth and the legendary Messenger probe confirmed that these dark craters host an estimated 1 quadrillion kilograms of water ice. This ancient water ice remains perfectly stable, resting in perpetual freeze immediately adjacent to the most scorched plains in the solar system. To understand the true internal nature of the planet nearest to our Sun, we must contrast it with standard astronomical objects. When studying a typical terrestrial planet, such as Earth or Mars, science demonstrates a very balanced internal architecture. These standard planetary bodies always contain a relatively small metallic core at their absolute center, which is wrapped beneath a massive, thick layer of rocky material known as the mantle and capped by an outer crust. This common structural layout acts as the foundation for our mechanical understanding of how rocky worlds operate. However, advanced observational astronomy shows that Mercury completely violates this fundamental rule of planetary formation. It presents an anatomical layout that is reversed, challenging our basic knowledge of the solar system. Instead of a standard rocky world, this bizarre body behaves like a naked anomaly drifting through the dark void, forcing researchers to rethink the entire evolutionary history of our local cosmic neighborhood. This structural deviation becomes clear when analyzing the internal layout of this world. Rather than a normal distribution of mineral material, Mercury is practically a giant cannonball made of dense iron traveling through deep space. Specialized measurements prove that its solid and molten iron core is absolutely massive, taking up approximately 85% of the entire volume of the planet. To contextualize this layout for a mainstream audience, the outer rocky mantle and crust together form a thin shell that is barely thicker than an eggshell, struggling to contain the heavy metallic heart within. Because iron is incredibly dense, this abnormal core gives the tiny planet a massive gravitational concentration. If this planet happened to be the same size as Earth, its surface density and internal mass would generate an identical intense gravitational pull. This extreme concentration of heavy elements makes it the second densest planet in the solar system, a fact that remains a core pillar in how this modern Universe Explained series unpacks the mysteries of creation. The existence of this metallic cannonball is the direct result of a violent historical event that researchers study within cosmology. Planetary scientists state that ancient Mercury was once a normal, fully formed planet that was likely twice as large as its current size, possessing a thick, rocky exterior just like Earth. However, billions of years ago, during the chaotic early era of the solar system, a massive wandering celestial body slammed directly into it. This historical collision was an extreme hit-and-run event of epic proportions. The sheer kinetic energy of the impact did not shatter the planet completely, but it was brutal enough to strip away the entire outer mantle of rock, blasting the fragmented crust into the deep vacuum of space. This left behind only a naked, bleeding core of iron to cool near the sun. This extraordinary collision cascade means that the planet we see today is not a complete world, but rather the leftover skeletal remnants of a planetary murder that occurred in the ancient past. Understanding these incredible mechanisms allows us to appreciate how raw physics shapes the layout of rocky worlds. Every new piece of data transmitted by space probes provides vital clues about these ancient impact dynamics, reshaping the fields of modern science and astrophysics. The scarred surface we observe today stands as a silent, charred monument to the tattered history of our stellar system. What would you feel if you saw this with your own eyes? To comprehend the remarkable environment of Mercury, we must investigate how the fundamental laws of time and motion undergo a complete transformation. On Earth, our common understanding of a day and a year is completely balanced. A single year, which represents the time our planet takes to complete one full orbital circle around the Sun, lasts exactly 365 days. Meanwhile, a single day, which is the time required for the planet to rotate once around its own internal axis, takes only 24 hours. This predictable cosmic rhythm forms the basic template for human civilization, structuring how we measure the flow of existence. However, the mechanical behavior of the closest world to our star completely destroys this balanced architecture. generating a temporal paradox that challenges normal human logic and introduces a state of absolute cosmic awe. This strange distortion occurs due to a complex mechanical link known in orbital physics as a 3-to-2 spin-orbit resonance. Because Mercury sits incredibly close to the massive gravitational well of the Sun, the intense tidal pull acts as a powerful brake, slowing down the planet's rotational movement over billions of years. Consequently, the world screams through deep space at a speed of nearly 47 kilometers per second, finishing one full orbital year around the Sun in just 88 Earth days. Yet, while its year is incredibly short, its rotation around its own axis is agonizingly slow, requiring 59 Earth days to spin just one time. The mathematical relationship between this rapid year and slow rotation creates a spectacular anomaly. From one single sunrise to the very next sunrise, a full solar day on Mercury lasts for an incredible 176 Earth days. This means that a single day on this scorched rock is officially twice as long as its entire year. This extreme temporal framework leads directly to an incredible visual phenomenon on the surface that planetary scientists describe as a beautiful cosmic glitch. The orbit of Mercury is not a perfect circle, but rather a highly eccentric, flattened ellipse. When the planet approaches its point of closest alignment to the Sun, a position known as perihelion, its forward orbital speed increases dramatically. Exactly 4 Earth days before reaching this point, a bizarre gravitational crossover takes place. The forward orbital velocity of the planet becomes temporarily faster than its slow internal rotational speed. To an observer standing directly on the bare, charred ground, the sky performs an impossible dance. The monster Sun, appearing 3 times larger than it does from Earth, rises in the east, slows down, stops completely in the black sky, moves backward toward the west, stops a second time, and then finally resumes its normal forward path toward sunset. This astonishing motion is a pure demonstration of raw mechanics in action, proving that gravity can bend our perception of celestial behavior. Every new simulation released by NASA confirms that this hesitation is a real physical event caused by orbital dynamics. Unpacking these mechanical truths reveals how different conditions near host stars can reshape the structural behavior of planets throughout various galaxies. This world remains a profound testament to how the laws of nature operate in the most extreme zones of our cosmic backyard, leaving us mystified by the sheer complexity of the universe. This unique interplay of gravity and motion is the absolute essence of science explained. To advance our comprehension of the solar system, we must examine a highly unusual phenomenon that blurs the line between rocky planets and active comets. In general education, astronomy students learn that comets possess long, glowing tails because they are made of primitive ice and dust. When a comet travels close to the Sun, the intense heat sublimates the frozen ice directly into gas, leaving a visible trail stretching across space. Rocky planets like Earth, Mars, or Venus do not exhibit this behavior because their crusts are solid rock, completely free of large drifting ice networks. Yet, the closest world to our star presents a magnificent contradiction to this basic rule. Despite being a heavy, solid sphere of dense minerals and metals, it manages to trail an enormous appendage through deep space, creating a state of deep tension and curiosity for researchers trying to map our planetary family. This bizarre structural feature is generated by a violent environmental mechanism known in physics as atomic sputtering. The Sun does not merely radiate peaceful light. It continuously unleashes a torrential stream of highly charged particles known as the solar wind, which travels through the void at a rapid speed of 1,600,000 kilometers per hour. Because Mercury lacks a thick atmospheric shield to deflect this onslaught, these high-energy solar ions slam directly into the bare ground with terrifying force. At the same time, microscopic meteoroids and tiny cosmic dust grains bombard the surface at extreme speeds, vaporizing topsoil on impact. This constant dual bombardment triggers a chaotic atomic chain reaction. The incoming energy physically detaches weakly bound, lightweight metallic elements, specifically sodium atoms, blasting them away from the surface rocks and sending them flying into the fragile local exosphere. Once these metal atoms are dislodged, a delicate principle of quantum physics takes control to shape the escaping material into a ghostly structure. Although light particles called photons carry no mass, they possess real physical momentum. As the released sodium atoms float above the ground, they absorb these incoming solar photons, receiving a gentle but continuous push directly away from the sun. This relentless radiation pressure acts like an invisible stellar wind, overcoming the weak surface gravity of the tiny world and driving the sodium gas backward into the dark void. This beautiful, haunting process builds a massive, glowing orange tail that stretches behind the planet for an incredible 2,500,000 kilometers. When photographed through specialized filter instruments from Earth, this massive appendage transforms the planet into a spectral, comet-like entity, dancing in the dark. The discovery of this volatile metal trail has caused the absolute collapse of traditional solar system formation theories within modern academia. For generations, academic models stated that any planet forming so close to a massive star would have its volatile, easily evaporated elements completely stripped away during its early birth. Conventional science assumed Mercury would be a simple, dry ball of highly resistant minerals. However, specialized spectrometers mounted on robotic spacecraft have disproved this idea, revealing that the ground is completely covered in volatile substances like sulfur, chlorine, sodium, and potassium at much higher ratios than those found on our own moon. This strange chemical reality proves our basic evolutionary models are incomplete, showing that severe cosmic forces can preserve elements in ways we do not yet understand. This world remains far more enigmatic than distant black holes or speculative alien life, presenting a concrete laboratory that advanced engineers like those at SpaceX might study to understand how solar radiation interacts with rocky crusts over billions of years. To push our journey further into the dark cosmos, we must observe the physical transformation of this nearby world, which introduces an unsettling reality for modern astronomy. When studying planetary evolution, beginners often think that celestial objects retain a fixed, unchanging size once they solidify. This stable assumption applies to major bodies like Earth, where the structural geometry remains relatively uniform over broad historical timelines. However, specialized investigations in observational mechanics prove that Mercury is undergoing a continuous internal collapse, a terrifying process known as global contraction. To make this clear for a mainstream audience, the phenomenon operates exactly like a smooth, fresh grape that slowly loses its internal moisture over time, causing the outer skin to huddle together, wither, and warp into a Van Veo sphere covered in deep wrinkles. This is the exact dynamic altering the closest world to our star. This profound disfigurement occurs because the massive iron core dominating the interior of the planet has been slowly cooling down over a timeline spanning billions of years. In fundamental thermodynamics, when a highly dense metallic mass cools, its structural volume naturally contracts. As this colossal core shrinks inward, it pulls the outer rocky mantle along with it. Because the rigid surface crust cannot shrink smoothly, the ground breaks under the immense compressive stress, buckling and collapsing in on itself. This global implosion fractures the ancient landscape, thrusting massive walls of solid rock upward to create towering, narrow cliffs called lobate scarps. A prominent geological expression of this active trauma is a massive curved fault structure known as Beagle Roops, which stands an incredible 3 kilometers high and tears across the surface for hundreds of kilometers. The entire world is actively shivering, quaking under persistent seismic forces as it literally crushes its own outer shell into a smaller, tightly bound prison. The structural vulnerability of this collapsing world becomes even more unsettling when analyzing its highly asymmetrical magnetic boundaries. Unlike normal terrestrial bodies where protective fields align neatly with the center, Mercury exhibits a highly distorted magnetosphere that is offset toward the North Pole by approximately 20% of the planet's entire radius. This bizarre mechanical shift triggers a severe environmental crisis for the landscape. While the northern hemisphere receives a small measure of protection, this significant displacement leaves the southern hemisphere completely exposed to the elements. The raw, torrential force of the solar wind rips through this massive structural gap, bombarding the bare southern crust with intense radiation cascades. This cosmic bias demonstrates that the physical defense systems of planets can be deeply unstable, far removed from the idealized balances traditionally taught in standard introductory textbooks. Reflecting upon this scorched wasteland brings our long interstellar journey to a slow, profound pause. For generations, casual stargazers assumed that reaching the inner system would be a simple task. Because Mercury sits so close to Earth on average, a direct flight path might appear shorter than traveling to the icy, frozen worlds orbiting the absolute edge of our planetary neighborhood. However, advanced engineers operating modern rocketry know that navigating this region requires a relentless struggle against intense orbital mechanics. Launching a machine to this heavy rock actually demands far more energy and propellant than sending a probe past the distant orbit of Pluto. The immense gravitational pull of our central star acts as a steep cosmic slide, aggressively pulling any approaching object down toward its blazing furnace. To avoid a fatal plunge into the sun, a spacecraft must engage in a prolonged braking process, skimming past the thick gas layers of Venus and Earth 9 separate times over 7 years to shave off its vital velocity. Despite these extreme physical cambi, human curiosity refuses to pull back into the shadows. Following the historical legacy of the Mariner 10 flybys and the groundbreaking discoveries transmitted by the Messenger orbiter, humanity has deployed its most complex machine yet. A grand joint venture between the European Space Agency and the Japanese Aerospace Exploration Agency has launched the Bepi-Colombo spacecraft. This advanced cruise module carries 2 independent satellites, known as the Mercury Planetary Orbiter and MEO, which travel in a united configuration. Once they settle into orbit, these robotic tools will separate to analyze the planet from entirely different angles. This mission will fundamentally illuminate the highly dynamic southern hemisphere, uncovering the elusive secrets of the asymmetric magnetosphere and mapping the chemical composition of the deep polar ice craters with higher precision than ever before. The harsh environment of this iron ball stands as a supreme monument to the raw, unyielding principles of creation, providing a perfect case study for our ongoing space theory series. Witnessing a world where days outlast years and mountains shrink under cooling metals does not mean physics is chaotic. The universe isn't broken. Our map of it is just incomplete. The strange behaviors of this small rock are not random glitches. They are valuable lessons proving that nature operates on scales that constantly challenge our narrow perspective. Every single crater scar and lobate scarp running across this charred landscape is simply a step on a grand cosmic ladder, enabling human intelligence to escape the boundaries of native ignorance and understand how stars shape their surroundings. What do you think? Does this change how you see our place in the cosmos? I'll keep exploring if there's more to uncover. Thank you so very much for watching.